Now this illustration is still dealing with transformer secondary conductors in accordance with 240.4F and 240.21C1. Now, these are conditions where a two-wire to two-wire transformer, the primary device can protect the entire system. This is dealing with a three-wire delta to delta, delta to delta, where the same permission is given here. Now, notice the same rule is applied. Calc 1, you take 480 primary, divide it by 240 volts secondary, and you come up with a 2-to-1. If you're dealing with the 400 amp overcurrent device on the secondary side of that transformer, you divide that by 2, and you could have a 200 amp device or less in the primary at the service equipment. Take the 200 amp now and multiply by 2, and you could have a 400 amp device in the secondary side of the transformer on the transformer secondary conductors, and a length is not given. The primary is protecting the whole system, overcurrent device. And that's what this illustration is showing. As long as you have a 400 amp main there, say, and 600 kc mil conductors, good for 420 amps, or parallel conductors that would give you 420 amp, then terminated to a 400 amp device, and this would be legal as shown in the boxed-in information applying 240.4F for a 3-wire delta and a 3-wire delta. And you notice the transformer is not grounded in any way. It's an ungrounded system. And notice step 1, 240 divided by 480 times 420 would give us 210 amps. And here they're taking the ampacity of the conductor, or you could take the overcurrent device and come up with the same thing. You would have to have a 200 amp device or less on the primary side for the overcurrent device on the primary to be considered protecting the entire system without a length on the secondary side of 10 foot, 25 foot, 100 foot, or any length as you want, applying 240.92E with the requirements of a supervised industrial location. Here, this could be applied in accordance with 240.4F and 240.21C1, and that's what our figure 9-9B is illustrating.